Hi everyone. Wanted to take a minute to go through the warm-up questions that I posted for you to do for your blended assignment for today. I do want to take a second and point out that if I'm taking the time to post a warm-up question for a blended day, and also I'm taking the time to make a whole video about those warm-up questions, there's a reason for that. They're important questions, meaning you're going to see them again, like maybe on the quiz that you have tomorrow. Okay, so you do want to make sure that you understand this question. Maybe after you watch this video, work through it again on your own, something like that. So we're looking at the equation x equals -5 here. This equation here. And before I start answering any of these questions, I want to just make sure we understand a couple of things about this function. Okay, so first of all, if I look at this as far as like a table of numbers, if I make like an XY table here, what is really going on in this function when I say x equals -5 is that the x is always -5. So in my table, all of my x's would be -5s. My y's could be anything I want, right? So my y might be a 1 or a -3 or a 4.7 or a 1,000. It really doesn't matter, okay? I can put anything I want down there for y. Okay, my x is always -5. And if I graph something like that, and give me just 1 second, I'll get a graph sketched here for you. So if I sketch a graph of something like that, where all of my x's are equal to -5, so if this was -5 right here, I might have -5, comma 1, -5, comma -3, -5, comma 4.7, -5, comma 1,000, which would be way higher than that, but that's okay. And so you can see that really what's happening here is I'm making a vertical line that really should go through all those points, but I'm drawing on an iPad, so leave me alone. Okay? Okay, so now let's talk slope and y-intercept of this line. Okay? For slope here, this is a vertical line, so my slope is undefined. And really, I hope you're at the point where you look at a vertical line and you say, okay, I know that has an undefined slope. But if you really wanted to, you could grab two coordinates out of the table here and do like y2 minus y1 and x2 minus x1. You would find that it would be something over 0, and then that would give you your undefined. Okay? My y-intercept, meaning my b value, well, if you look at the graph here, this thing never crosses the y-axis. Here's y, right? And this thing is going to run parallel to that. It runs straight up and down. So it's never going to cross the y-axis, meaning that I have no y-intercept. Kind of a trick question there. Okay, my slope is undefined and I have no y-intercept. Okay, name 3 points on this line. Well, I kind of did that over here, right? When we made up our coordinates. They could be anything as long as it starts with -5. So -5, comma, something. Okay? And I would want you to list 3 specific points. Let's talk domain and range, because I know domain and range are still tricky for us. But I really think for domain and range, the easiest thing to look at is this table that we made for ourselves back here. Okay? When I say domain, I'm saying what is x allowed to be? And according to this table, x always has to be -5. Okay, so my domain is just x equals -5. Always. That's the only thing x is allowed to be. Okay, for my range, I'm saying what is y allowed to be? So again, looking at this table at my y values, what did we say about y? Well, a minute ago, we said that y could be anything we want. And so the mathematical way to say that would be all real numbers. Okay. Looking at the graph, you can see that same thing. As far as an x value from left to right, the only x value this one ever covers is -5. It never moves to the right. It never moves to the left. It always stays at -5, okay? Which is why my domain is -5. But my range, it goes up forever, down forever. It covers every y value you can imagine, and so that's why my range is all real numbers. And then is this a function, y or y not? Well, looking at it on a graph, I would say no, because this thing fails the vertical line test. If I draw a line right here, it's hitting more than 1 point. For my table, I would still say no, because notice that my x's double up. So I don't care which one of those you use as an answer. I'm going to write the easiest one to write because, again, I'm writing on an iPad. So no, it is not a function. And I would say fails vertical line test. Okay, on the graph. If I'm looking at a graph, I can say fails vertical line test. If I'm looking at a table, then I might say something more like, well, some of the x's have duplicate partners or something like that. Okay, that's it for this question. Let's move on to the one about the delivery truck. Okay, so carrying on here, let's see. Delivery truck driver is traveling between two distribution centers. They are 220 miles apart. Truck is traveling at an average of 65 miles an hour. Let's see if I can shrink this and move it out of the way here. Okay, so let's draw some pictures. Oh, and I'm sure you're going to love my picture drawing here. Okay, you thought they were good in class. They're even better on the iPad. So I've got two big, boring distribution centers here and here. Okay, here's the road that leads between them. And I know that these two things are 220 miles apart. So my total distance is 220 miles. Okay. My truck, let's see, how about a nice shiny red truck? My truck is right here. Okay. And it's traveling from this distribution over to this distribution center. Okay. So it's somewhere in between, traveling at 65 miles an hour. And so what I want to do is I want to represent how much farther do I have left to go. Picture like a little kid in the back seat going, how much longer? Okay. Except we want to talk distance in miles, not time necessarily. And so we want to write this as a function of time though. So as far as my equation goes, I know this is kind of hard to think about. This doesn't match the format of some of our other questions. But when we first leave the distribution center, okay, when we are, standing right here, or when our truck is about to pull out of the driveway right here, I can say that my distance, that my D value would be 220. Okay, so again, if I am pulling out of the driveway right here, I have 220 miles before I get to that other distribution center. Okay. And then as I drive, so as I'm moving this way, my distance is shrinking, right? And it's shrinking by 65 miles every hour. Okay, so my distance starts at 220 and then it shrinks by 65 miles every hour. That, I think, is the easiest way to think about this equation and what it should look like. Okay, that I'm starting with a distance of 220, and then as I drive, that distance is slowly shrinking by 65 miles every hour. Okay, so there's my equation. That's my first bullet point up there. Okay, that my distance will be 220 minus 65 times h, where h is my number of hours. Oh, I think I said to use t. Whatever, it doesn't matter. Okay. Driver will stop for a break when he is 50 miles away from the second distribution center. So that's not after 50 miles. That's not when he's driven 50 miles. That's when he has 50 miles left in front of him. Okay? And so really that means that I want the 50 to be plugged in here for my D value. So I'm going to go over here and solve. I'm going to say 50 equals... let's see. Gosh, my pen is not working very well. 220 minus 65h. All right, and then I'm going to solve this thing. So I am doing 50 minus 220 in that order. And I come up with negative 170. So that's me moving this over here. I get negative 170 equals negative 65h. Okay. And then I'm going to divide by that negative 65. And I end up with 2.6 something something. 2.62, I guess, is h. So after a little more than 2.5 hours, I get to stop to take a break. Okay, that's what I just found. And so really, some of you might be looking at that like that was a dumb question because we went to all this trouble to write this equation, right? But really for this, if I have 50 miles left to go and I subtract, that would mean after I've driven 170 miles. So some of you may have been able to reason this out without necessarily writing this equation, but the question did ask for an equation. So since we had it, we may as well use it. Okay, but really I think the setting up of that equation and understanding why it's written the way it is the most important part of that question. So you will definitely want to know that before you take your quiz tomorrow. Okay, please come in tomorrow ready to ask questions about your lesson masters or this warm-up or anything you feel like you need to go over again before we take the quiz. All right, have a great night.